Good morning, everyone. Here we are with chapter number 5 from your textbook, and the name of chapter is Gravitation. This chapter is there for 5 marks without option and 7 marks with option in your theory part. In this chapter, we are going to discuss about something very interesting and important about gravitational field, gravitational force. As an introductory part, we all know that each and every material object have a natural tendency to get attracted towards the earth. In day-to-day life, we experienced many phenomena regarding this. All bodies are attracted towards the earth with constant acceleration. This fact was recognized by Galileo. To prove this thing, he done with one experiment. In his experiment, he released two balls of different masses from top of the Pisa, which reached the ground at the same time. To discuss these kind of things further, there are number of scientists. They proposed n number of things in front of us. Start with Indian scientist Aryabhatta. According to him, the motion of the moon, earth and other planets, earth revolves about its own axis and it moves in a circular orbit around the sun. Also, moon revolves in a circular orbit around the sun. After Aryabhatta, there was a scientist named Kepler. He studied planetary motion through the careful observations. He analyzed a huge data regarding that and established 3 laws of planetary motion. The reason why planets obey these laws was provided by Newton afterwards. According to him, gravitation is the phenomenon which is responsible for keeping planets in their orbits around the sun. Every massive object in the universe experiences gravitational force. It is the force of mutual attraction between any two objects. This force is not dependent with any intervening medium. So this is all about like an introductory part. Moving towards the core part of this chapter, we'll start with Kepler's laws. These laws describe the orbits of the planets around the sun. These laws are the result of the analysis of data collected by Tycho Brahe through the years of observation of the planetary motion. The first law given by Kepler is called as law of orbit. All planets move in an elliptical orbit around the sun with the sun at one of the foci of the ellipse. You can see that everything in given diagram. So as we know that if I consider these axes, one is major axis, one is minor axis, and let us consider this is point A, this is point O, and this is point B. So from A to O and O to B called as semi-major axis. Let us consider this is P and Q. So from P to O and Q to O, they are called as semi-minor axis. So according to this, when sun is at one of the foci of the ellipse, all planets move in elliptical orbits around the sun. This law is called as law of orbits. Second law is law of areas. According to that, the line that joins a planet and the sun sweeps equal areas in equal interval of time. In other language, the radius vector drawn from the sun to a planet sweeps out equal areas in equal interval of times. That is, the areal velocity means area covered per unit time of a planet around the sun is always constant. We can prove this law. For that, we are going to consider the conservation of angular momentum. According to that, if torque acting on the system is 0, that is external force, then total angular momentum always remains constant. This is valid for any central force. The central force means the force which is always directed along the line joining the position of object and a fixed point usually taken to be the origin of coordinate system. The force of gravity due to the sun on the planet is always along the line joining the sun and the planet. Therefore, this force is the central force. As we all know that tau is equal to, that is torque is equal to R cross F. According to law of conservation of angular momentum, tau is equal to dl by dt is equal to 0, then L is equal to constant. Let us consider the area of triangle is delta A. Delta A is given by half R cross P. Now we know that according to product form, the vector can be divided as first into derivative of second into plus second into derivative of first. Now if I consider R cross P, at that time I know that if I consider P is equal to mv, then in place of V I can substitute P upon m. So delta A upon delta T will be equal with half R cross V. I can write that equation as delta A upon delta T half R cross. In place of V we can substitute P upon m. So this will become half R into P upon m. Delta A upon delta T further equal with 1 upon 2m in bracket R cross P. But R cross P is equal to angular momentum given by capital L. Therefore, this will become delta A upon delta T is equal to L upon 2m. Now, L and m are constant. That's why delta A upon delta T also equal to constant value. In this way, we can prove the law of area. This is a consequence of the gravitational force being a central force. So, I'll repeat the law again. In all planets, the line that joins a planet and the sun sweeps equal areas in equal interval of time. So delta A upon delta T is always equal to constant. Moving towards next law of planetary motion. When you consider third law is law of period. According to the law, the square of the period of revolution of the planet around the sun is proportional to the cube of semi-major axis of its elliptical orbit. In other words, the square of the time period of the revolution of a planet around the Sun is proportional to the cube of semi-major axis of the ellipse traced by planet. So according to this, normal is t square is proportional to r cube. Here you can see, if you want it in detail, suppose a planet of mass m moves around the Sun in a circular orbit of radius r with orbital velocity v. If I consider mass of the Sun is capital M, the force of gravitation between the Sun and the planet provides the necessary centripetal force. So we can write, as we all know, that mv square upon r is equal to centripetal force, and this is value of gravitational force, that is gmm upon r. So mv square upon r is equal to gmm upon r square. According to these equations, v square is equal to gm upon r. But as we know that v is equal to distance upon time period, but here we are going to consider revolution. That's why distance covered by the particle is circumference of the circle, and divided by time period of revolution, it will become 2 pi r upon t. When you compare these both equations after squaring the second one, you will get t square is proportional to r cube. So this is third law of Kepler. So in short, there are three laws. First, law of orbit. Second, law of areas. And third one, law of period. Moving towards next point. Now we are going to discuss about universal law of gravitation. When the objects are released near the surface of the earth, they always fall down to the ground. It means the earth attracts object towards itself. According to Galileo, when we consider any heavy and light objects and they released from the same height fall towards the earth at the same speed, it means they move with the constant acceleration. But beyond that, Newton proposed that the force of attraction between masses is universal. Newton studied the motion of moon around the earth, and when the motion of the moon around the earth was studied, at that time it is almost a circular orbit around the earth with constant angular speed. The moon must be constantly acted upon by a force directed towards the earth, which is at the center of the circle. As we all know that the centripetal force is given by mr omega square, and F is equal to ma2. Therefore, ma can be equal with mr omega square. So when you consider the law of nature are the same for earthly objects and for the celestial bodies, as this acceleration is much smaller than the acceleration felt by bodies near the surface of the earth. According to this, we conclude one law, that gravitation is a natural phenomenon by physical bodies attract each other. He focused on his attention on the motion of the moon about the earth. He declared that the laws of nature are operating between earth and the apple is same as the laws of operating between earth and moon. After these number of after these number of phenomenons, he concluded that A is inversely proportional to 1 upon r square. Also, F is directly proportional to m. So you can write F is proportional to m upon r square. By the third law of motion, the force on the body due to the earth must be equal to the force on the earth due to the body. Therefore, this force should also be proportional to the mass of the earth. Thus, the force between the earth and the body is F is proportional to mm upon r square, where we consider capital M is the mass of the earth and small m is the mass of the planet or moon or any object. When you remove this proportionality sign, F will become capital G mm upon r square, where that G is gravitational constant we consider as the universal constant of gravitation. According to that, the value of G is equal to Fr square upon m into m. So its unit is Newton meter square per kg square, and please underline this value. The value of capital G is 6.67 into 10 raised to minus 11, followed by the unit Newton meter square per kg square. Now, this law is applicable to all material objects in the universe. That's why it is known as the universal law of gravitation. You can write this formula in vector form too. So when you consider the object is at center O, m1 is a mass of one body, m2 is mass of another body. Vector r1 is position vector of vector OM1. Vector r2 is the position vector of OM2. And this is vector r21, which is a relative vector between these OM1 and OM2. So, r cap 21 is the unit vector from M1 to M2. The force F21 is directed from M2 to M1. Similarly, the force experienced by M1 due to M2 is F12. So, as we all know that F is equal to G M1 M2 upon R square. In vector form, this formula can be turned as vector F12 is equal to G M1 M2 upon R square into due to direction of position vector minus R cap 12. So you can write vector F12 is equal to vector F21, but it's oppositely directed. So F12 is equal to minus F21. I hope you understood this concept of universal law of gravitation. Why we require this law? What are important features of law of gravitation? The gravitation force between two masses is independent of the intervening medium. The mutual gravitational forces between two bodies are equal and opposite. The gravitational force is conservative force. The law of gravitation holds only for point masses. The gravitational force between two point masses is a central force. Its magnitude depends upon r and has no angular dependence. The gravitational force between two bodies is independent of the presence of other bodies. So this is whole and soul about Newton's law of gravitation, which is considered as a universal law. Moving towards next point, we are going to start with few basic equations that are value of G, that is acceleration due to gravity of the earth, then what are effects of altitude, latitude and depth on that particular value of G. So let's start one by one. First of all, we are going to discuss about acceleration due to gravity itself. Here we are going to consider the body having mass m is situated outside the earth at the distance r from the center. The gravitational force on the mass is F is equal to mv upon r square. F is equal to mg2. Therefore, mg is equal to gravitational force is gmm upon r square. When mm gets cancelled, the value of g remains gm upon r square. So according to this, we can say that the acceleration due to gravity is independent of mass of that particular particle. So just make the square for this term. G is equal to gm upon r square. Next point, variation of G with respect to altitude. We are going to consider a body placed at point P above the Earth's surface, having height h from the surface. We know the value of g is given by gm upon r square at the earth's surface. Now for height h, it will consider, gh is equal to, in place of r, it will turn r plus h. That's why gh is equal to gm upon, in place of r, we have to substitute r plus h bracket square, but it is at point m. Now dividing equation 2 by equation 1, that is at height h and on the earth's surface, we'll consider gh upon g is equal to gm upon r plus h square divided by gm upon r square. Gm gets cancelled. Gh upon g will be equal with r square upon r plus h bracket square. Gh upon g will equal with, again you can consider it as a r square upon r square combined ले लो, remaining term 1 upon h upon r. I hope you understood these things or these steps. Gh upon g, here I think it should be gh upon g. So gh upon g is equal to r square upon r plus h bracket square. So gh upon g will become r square upon r square combine ले लीजिए, इसमें से बचेगा 1 plus h upon r whole bracket square. Then gh upon g will be 1 plus h upon r raised to minus 2. Therefore gh upon g is equal to, as we all know that 1 plus x raised to n will be equal with 1 plus nx, or 1 minus x raised to n will be 1 minus nx. So in that way you can take this as a gh upon g is equal to 1 minus 2h upon r. According to this, we can say that g decreases as the height increases. Therefore there is definitely effect of height or altitude on the value of g, and which is given by gh is equal to g into 1 minus 2h upon r. So whenever you consider this value, the value of g will change as the multiple of 1 minus 2h upon r. Next point, due to gravity, how the value of this term will get changed. Here we consider the body placed inside the earth's surface or below the earth's surface at the distance d. As we all know that g is equal to gm upon r square. Here the body is inside the earth's surface, below the earth's surface. So mass is equal to volume into density. As we consider earth as a solid sphere, that's why volume is 4 pi r cube. 4 by 3 pi r cube, and density as a rho. Therefore g will become g into 4 by 3 pi r cube rho divided by r square. At the earth surface, the final value of g will become g into 4 by 3 pi r rho. For depth d, it will become g 4 by 3 pi r minus d into rho. Let's divide these both equations. Gd upon g, 4 by 3 gets cancelled, g gets cancelled, pi gets cancelled, again rho also gets cancelled. Remaining term gd upon g is equal to 1 minus d upon r. Therefore gd is equal to g into 1 minus d upon r. As per g increases, there is increase in depth too. So value of g depends on depth also. You can see the graphical nature, the variation of g with respect to depth and height. As we all know that the variation of g with respect to height will never be zero. It will increases after certain height. And for depth, the variation of g with respect to depth will be zero when the body is placed at the center of earth. Third point, the variation in g with latitude and rotation of the earth. For that, let us consider the body is revolve around its own axis. ये जो बड़ा वाला सर्कुलर फॉर्म पाथ हमने दिखाया है वो हम कंसिडर करते हैं. The body is moving about its own axis and this is radius, that is OE. Now what is latitude? It is an angle made by radius factor of any planet from the center of Earth with the equatorial plane. Its range varies from 0 degree at the equator and 90 degree at the poles. Now when we consider regarding this diagram, we are going to consider PO dash is R, EOP as theta, similarly OPO dash as theta all. So in OPO dash we can write cos theta is equal to adjacent upon hypotenuse. So PO dash upon PO. As we know that PO dash is small r, PO is capital R, it will turn as the small r upon capital R. Value of small r becomes r cos theta. Now centripetal acceleration given by r omega square, substitute value of small r over here, it will become r omega square cos theta. It has to be r omega square cos square theta. Now the component of centripetal acceleration along PO is given by a cos theta. Now we know that value of a is r omega square cos theta into cos theta. It will turn as r omega square cos square theta. Now let us consider this part of the gravitational force of attraction on P acting towards PO, providing us number of components. Therefore, the effective force of gravitational attraction on the M at P is written as mg dash is equal to mg minus this term of acceleration mr omega square cos square theta. Gets cancelled, remaining term g dash is equal to g minus r omega square cos square theta. Now there are two conditions. One is theta is equal to 0 at equator and at pole theta is equal to 90 degree. We know that cos 0 1, cos 90 0. So for theta is equal to 0 degree, the equation will becomes g dash is equal to g minus r omega square, and at pole g dash is equal to g. According to these all things, we conclude that definitely there is effect on value of g due to altitude, due to latitude, due to depth. But again, effect of shape of the earth also the important point over here. We consider the earth to be a sphere, but it's not actual fact. Actually, it's in the shape of ellipsoid. Therefore, equatorial radius of the earth is greater than the polar radius. Therefore, on the equator, there is a combined effect of greater radius and rotation in reducing the force of gravity. You can see both values over here. Weight of an object is the force with which the earth attracts the object. Therefore, weight W is equal to mg. As the value of g changes with altitude, depth and latitude, the weight also changes. It is minimum at equator and it reduces with increasing height above the earth's surface and with increasing depth below the earth's surface. Let's stop here for today. In tomorrow's lecture, we are going to discuss about gravitational potential, potential energy, concept of potential, escape velocity, critical velocity, binding energy and few more points. I hope you understood. Thank you.